this is exercise 11B. Right, so this is 11B, question number 5. A particle P moves in a straight line at time t seconds. The acceleration is a meter per second and velocity is v meter per second. Given by an expression, so let's just write down that expression. V is equal to k times t minus 3t squared, where k is some constant. The second data that we know is the initial acceleration is 4. That means when t equals 0, a is equal to 4. That is what initial acceleration kind of implies. We need to figure out the value of k. So you can kind of connect the dots here. The question is given in terms of v, but the data that they have provided is in terms of acceleration. So we have to change the velocity into acceleration. So we have to differentiate this. So I can say acceleration is dv over dt, which would be k is some constant, so do not differentiate k. If it was 3t, I would have got the differential as 3. So the differential of kt would be k. And the differential of minus 3t squared, that would be minus 6. So I know that the expression for acceleration is k minus 6t. My bad, k minus 6t, and I know that when t is equal to 0, a is equal to 4. So if I plug in that condition, when t equals 0, I get a is equal to k, and I know that based on the data, this is supposed to be equal to 4. That means k is equal to 4. So we use the data that is given to us, but the data was in the form of acceleration, so I use the expression to differentiate it and get to acceleration. Part B says, using the value of k, find the acceleration when p is instantaneously at rest. So they didn't say find the value of acceleration when t is equal to 3 or t is equal to 5 or anything of that sort. So this is a question inside another question. So first we have to find out when is p instantaneously at rest. So if I have to figure out when is p instantaneously at rest, I have to figure out when is velocity equal to 0. Now I know the expression for velocity is kt minus 3t squared, and I know k is 4. So this is 3t minus 3t squared equal to 0. So we now have t times 4 minus 3t equal to 0. That means there are two instances where the object is instantaneously at rest. One is when t equals 0 and the other when t is 3/4. So we have to find out the acceleration when t is equal to 0. Oh, my bad. So that is 4 over... when t is 3 over 4 and when t is 4 over 3 and when t is equal to 0. So when t is equal to 0, acceleration would be equal to, if I plug in t as 0 in acceleration, I get 4. If I plug in t as 4 over 3, acceleration would be equal to 4 minus 8, which is minus 4 meter per second squared. Did I get this right? Or is it a different answer? Same thing? So that is part A. So you have to do this for t equals 0 and when t is equal to... please don't skip this part, because if you skip that one, that doesn't add up, because that is also an instant when it is instantaneously at rest. So you have to take into account t equals 0 and also t equals 4 over 3. So that is question number 5. Question number 6. This time you've got a printer head that moves from side to side. So if you have seen the inside of a printer, you know how the printer head moves from side to side. And we are measuring the displacement of the printer head from one of the sides. So you're going to take one of the sides as origin and you are measuring how far away is the printer head from one of the sides at every instant of time. We have to find the distance between the points when the printer head is instantaneously at rest. So again, we have to know when is it instantaneously at rest. If I have to figure out instantaneously at rest, I have to figure out when does velocity become 0. Unfortunately, I don't have velocity. All I have is displacement, which is 1/4 4t cubed minus 15t squared plus 12t plus 30. So I don't have velocity, so we have to change this to velocity, which means you differentiate this thing. One tip that I can give you is don't bother multiplying the 1/4 inside, because when you're differentiating, timesing the quarters doesn't really make any impact. So you can say your velocity is 1/4 of, now differentiate what is inside. So 4t cubed, Yaqub, what does that become? When you differentiate it, that will be 12t squared. Zuhair, can you give me the next term? Minus 30t. Samhan, can you give me the next one? Plus 12. And Alethea, what happens to 30? That just goes away. So velocity now is, I have an expression for velocity now, which is this right here. So for instantaneously at rest, I have to say, for rest, this has to be equal to 0. And I could actually figure out the roots of the expression that is inside, because 1/4 doesn't really make an impact. Plus 12 equal to 0. Can somebody tell me the roots? T equals 2 or t equals a half. These are the two instances where the printer head is instantaneously at rest. So I have to find the distance between these 2 points. So let's see. When t equals half, where should I plug in the t equals half? Because we are trying to find the distance between these 2 things. So I should plug this into the distance thing. So when t equals half, I have displacement is 1/4 4 times 0.5 cubed minus 15 times 0.5 squared plus 12 times 0.5 plus 30. Can somebody tell me what would that become?
It becomes 8.8.
8.8. 8.2. Oh, 8.8 to 2 significant. Can you give me to one decimal place? Same thing?
Yeah,
8.8. 8.8, is it millimeters? What is it? Centimeters.
Sorry, my bad. 8.1. 8.2.
Can we all agree on an answer? 8.2. So 8.2 centimeters. So that means when the time is half a second, the printer head has reached 8.8 centimeters. Now can you try the same thing for when it is 2 seconds, please? See what you get?
6.5.
When t equals 2 seconds, s is equal to 6.5. Is there something wrong with our answer? Because the printer is supposed to be moving forwards, right? Why do we get a 6.5 now? Does that mean our math is wrong? No? Because the printer head moves back and forth. So initially it was moving that way. We didn't know what happened between 2 and half a second. It might have gone to the very edge, and when it is 2 seconds, now it is coming back. That is why so this was 0.5 seconds. Maybe at 1 second it has reached that end, and for the others it is returning back. So this is the return journey. On its return journey, when t is equal to 2 seconds, it has reached the point which is 6.5 centimeters away from the printer head, or from the side that we are measuring. So I want to figure out the distance between these 2 points. So if I want to find the distance between these 2 points, that will be 8.8 take away 6.5, which should be 2.3. But I know you're clever, you can all do this in your head, but please write 8.8, take away 6.5. That counts as a method mark. It's 8.2, my bad. So that's 8.2, take away 6.5, which is 1.